Okay, today we're going to talk about arcs and sectors dealing with circles. And so the first thing I want to talk about is some angles related to those. And this first one, we're going to look at it because it has the vertex of the angle on the center of the circle. It's called a central angle. When it's like this picture over here and the vertex is on the edge of the circle, that is called an inscribed angle. And the thing that you need to know about these is obviously angles are measured in degrees. The arc that goes with it is measured in degrees. So for this one, this arc here, it's going to be the same measure as this angle for a central angle. So a central angle equals the measure of the arc. In the inscribed angle, if you look at the arc, whatever that measure is in degrees, the angle over here is half of that. So for an inscribed angle, it is half of the measure of the arc. Okay, so in other words, if I just made up some numbers here, if I said this arc is 40 degrees, now I'm not drawn to scale by any means, but if this arc were 40 degrees, this angle would also be 40 degrees. Over here, if this arc is 40 degrees, this angle is 20. So that's the difference on having your vertex on the center or having it on the edge of the circle. Now, sometimes you don't want to know the angle measure, the degrees, you want to know the length. So if this were a curve that your car was traveling on, you want to know this distance right here that your car would actually travel. And so the way that you're going to figure that out is, again, using this angle. What I'm looking for is called arc length. That means it's an actual distance that we're trying to find, not just a degree measurement. And the way you find that is by taking the angle, the central angle that you know, and putting it over 360. So you're making the relationship of as part of a whole, because a whole circle is 360. But the distance around a circle is circumference. So you will multiply that fraction by circumference, which is 2 pi r. So some of you need to think of it as angle over 360 times 2 pi r. Okay, so let's say we have this problem where you have a central angle of 120 and a radius of 8 centimeters. If I asked for the measure of the arc AB, I might ask it like this. The little arc over the AB tells me that's that arc. And I'm going to say that I'm referring to this minor arc here, not the major arc. That measure, since this is a central angle, would also be 120. If I wanted the arc length, that would be the actual distance. So I would do the 120 over 360 to get that ratio, and then multiply by circumference, which is 2 pi r. And that would give me about 16.75 centimeters. So obviously I'm not drawn to scale, but that's with a radius of 8 centimeters and an angle of 120. That distance from A to B or B to A would be 16.75. Okay, sometimes you need to find the area of a shape like this. And this is just a central angle in a circle, but we want to know all of the area in that space created by that angle. That is called a sector. So we are trying to find the area of this sector, kind of like the cheese on a piece of pizza. And it's really similar to what we did for arc length because it's a part of a whole. And so that area is going to be that angle over 360 again, because you need that ratio of the whole thing. But since we're finding area, you're going to multiply it by the area of a circle, which is pi r squared. Okay, so now for an example, let's say we wanted to know the area of this large sector up here. And what we know that's given to us is that the radius is 5 inches and that this angle that we don't want is 160. That is actually going to make us do a little bit more math than normal, Since a circle adds up to 360, you know that if 160 is white, then the 200 would be pink. And so that's the big angle that we need to do our calculations. Since this is a sector and we're finding area of a sector, I'm going to do that 200 over 360 to get that angle relationship. And I'm going to multiply by pi r squared, because that is the area formula of a circle. If we type that into our calculator, we get about 43.63. Since we know the radius is in inches, this would be inches squared because it is an area.